Jake Helm here with another episode of Math Brains. Speaking of Math Brains, here comes world-renowned mathematician Dominic Cunico. Thank you everybody for tuning in. Today I'm going to be talking about the Unit 3 Math at Byron Middle School Math 7. Sweet. This is going to be interesting. You got that right, Jake. So here we go. So we need to talk about 3.1 first because, well, 3.1 is the start. So here's a review. So when numbers or letters are next to each other, that means that you multiply them. You know that, right? So the distributive property makes like long stuff easier. So let's say we had 28 times 1 plus 28 times 2. Instead of writing all that out, we could just write 28 parentheses 1 plus 2. Or, like, say you had 28, and then you just had 28, and then parentheses right next to it, and in those parentheses was 1 plus 2. Instead of just doing the 1 plus 2 first, like PEMDAS would say, which you will learn about later, you can just do 28 times 1 plus 28 times 2, and then you'll ultimately get the answer. Yeah, but we're making it easier. So then 1 plus 2 is 3, and then 28 times 3 will be the same answer as 28 times 1 plus 28 times 2. So that was pretty much what we have for 3.1. 3.1. Just the start. We're not over yet.
So, on to 3.2.
Yes.
So, 3.2 is order of operations, in which Jake said
PEMDAS.
PEMDAS. So, PEMDAS pretty much means this is the order that you're supposed to do stuff. So, first you're supposed to do anything in a math problem that has parentheses around it. Then you're supposed to do anything with exponents. Then you're supposed to do multiplication and division in order from left to right.
Just like you're reading a book.
Then you do addition and subtraction the same way as multiplication and division. So that's kind of what PEMDAS and order of operations is. So let's go to 3.3, exponents.
Jazz hands.
Yeah. So exponent. So back to exponents. Sorry, we had to take a commercial break.
Just a quick commercial break. Yep.
So let's say we were going to write 4 times 4 times 4 times 4
times 4.
Okay, we could just write 4 with that little number being a 5. Because that means 4 times 4 times 4 times 4 times 4. But if we write the 5, it saves us a lot of writing and paper. Save the trees. So,
hashtag save the trees.
So the 4 in this problem would be the base, which is the number being multiplied by itself. The exponent in this case would be the 5, which tells how many times the base should multiply by itself. Using an exponent can also be called raising to a power. The exponent represents the power. So in expanded form, you have to write all those numbers out. But with the exponents, it's easier. So let's see, what would we do if the base was a negative? Well, then we would have to count how many times it is. So if the exponent is a even number, it would be a positive answer. But if the exponent was an odd number, then it would be negative. So that's what you do if the base is negative. If the exponent is negative, you make that number. So if it was 2 to the negative second, it would be 1/4, because 2 to the second, 2 squared is 4, and then since it's negative, you do the reciprocal, which means you flip it. So it would be 4 over 1 as a fraction would be 1 over 4 with the reciprocal. So now we get to do 3.4, which is variable expression.
Yeah, jazz hands. Love jazz hands.
Let's say you have a job that earns $8.15 an hour. What could you do to quickly find out how much money you would work for different hours of work? You could make a list of all the possible hours, but that would take forever. So instead, you let the hours of work be replaced by a symbol, like H for hours. So then it would be, the amount of money would equal 8.15 times H. So H would be a variable, which is a letter that can be replaced by any number. But we don't know that number. So now we get to go to 3.5, simplifying expressions. Bang! So like terms are when the variable is the same. Unlike terms and when the variable is not the same or there is no variable on one problem. So let's say if it was 6a plus 3a would be 9a. Because that makes sense.
And then, like, if they're different, it would be 6. If you do 6a plus 9b,
it would be 9.
Then it would just, that's as far as you could simplify it. It would be 6a plus 9b. That would be your answer.
Mm-hmm.
Get it? 9b. That would be your answer. Yeah, corny jokes.
All right, we have it all on Math Brains. So,
you know it.
So if we had 12x minus 2x, the answer would be 10x. And so you get the point. But if we had 7y plus 2x, you wouldn't be able to simplify it anymore. That would be your simplest answer. So that's 3.5, and that's our episode of Math Brains.
We will return for the short leaving after this commercial break. And back with that special goodbye. So there was just little predicament after.
Just a little.
Yeah,
one.
during the commercial break, I might have kind of sort of spilled coffee on our shirts, so we got new stuff on. But let's get back to the show. So we have just heard
a new Unit 3.6
has just released.
And it's solving and evaluating expressions.
Oh my gosh. Dude, it's so crazy that it's actually here. Like, I've been waiting for so long
I know.
for another one to come out.
I've been waiting so long too. Because we've had like a couple of days where it's just like, there's nothing really to do.
Well, I mean,
so we're
like before the show, it was kind of hard finding anything to do on Math Brains just because, like, and I'm like, oh, there's this smart guy named Dominic who's might be willing to come in. And I, gave him a call and
yeah, all for it.
Yeah.
So
Unit 6.
3.6, solving and evaluating expressions. An algebraic expression is a mathematical phrase involving letters, numbers, and operation symbols. But it will not have an equal sign. You get that right? It will not have an equal sign. Okay, got it.
Just telling him something.
So a variable can be any letter, such as X, M, R, Y, B, A, and other letters.
Yeah.
That we could use in an expression. The variable represents possible values of a quantity.
That's
Take a look at the following examples of variable expressions.
More like take a listen. Corny jokes.
So, a variable expression is used to describe real-world situations when we don't know a value or quantity. Sometimes a value is dependent on a changing variable. So here, back to one of those variable expressions. 10
k minus 44. What would be the answer if k was 12? Then it would be 12 times 10, which is 120, minus 44 is 76.
Okay, that is
Pretty good for a new unit
yeah.
thing.
Sounds like you took some time listening to these. Well, is that it?
That's it for 3.6.
That is it for our third episode of Math Brains. Thank you all for listening and have a great
Rest of your day.